Hello, everyone. Thank you for joining the National Stock Assessment Science Seminar Series. My name is Bailey. I coordinate this monthly seminar series highlighting interesting advances and topics in stock assessment science. Today, we have Dr. Jason Cope with us. Jason joins us from the Northwest Fisheries Science Center. He performs groundfish stock assessments for the Pacific Fisheries Management Council, and he is actively engaged in collaborative efforts worldwide. During today's seminar, we'll look at the Stock Assessment Continuum Tool. So now with that, I'll pass it over to Jason.
Hi, thank you so much. Thanks for the invitation. If you are on the West Coast, thank you for spending your lunch time with me. If you are outside the West Coast, elsewhere, I appreciate your time that you're spending as well. It is indeed 2024, not like my slide says, but it is February 1st. Welcome to February, everyone. And thanks for jumping into the Stock Assessment Continuum with me today. I want to just share with you some ideas that I've been working on and would love feedback, collaboration, all those good things. I want to start by just going through this idea of what a Stock Assessment Continuum is. I then want to share with you some of the past work we've done on unifying different types of stock assessment through a common statistical catch-age framework. And then I want to present to you a shiny tool that I've been developing called the Stock Assessment Continuum Tool that I hope is of interest to you and freely available and would love your feedback on. So let's kick it off with understanding the Stock Assessment Continuum, but we should probably just make sure I define what a stock assessment is. A stock, complicated definition, is, for simplicity's sake here, a fish population defined in some way. And an assessment, we are, I think, familiar with this idea of measuring the health of something, assessing how something is doing. So a stock assessment is typically some sort of tool, analytical means by which we measure the health of a fish population, and we are often doing this to balance our conservation and management purposes here in the United States and around the world. If you start to look at the types of stock assessments, you can get quickly overwhelmed. There are lots of acronyms, lots of variations on the theme of trying to come up with some sort of indicator that measures the health or status or something you're interested in a population. And if you look at a little closer, you can even group these by, say, the types of data that they require. But there's a lot of them. And I was thinking, what is it? What could we use as a word that could kind of summarize a collection of stock assessments? Now, some of you may have heard me tell the story. I'm not going to tell the whole story, but I once took my kids to a pond and tortured them with a little stock assessment, asking them to go and enumerate the male and female ducks. And you could tell the difference between the sexes. And I just said simply, can you count these? And I think they bailed on me about 30 seconds in because they complained by the fact that some of them would go under the water, then they come back up and they had to start counting again. Some would fly in and fly out. They would lose count, all of these excuses they had for me. And so it was my demonstration to say, hey, it's hard to count things, right? But we use these stock assessments, we try to do those things. And while thinking about this duck analogy and trying to count simple ducks in a contained space and how hard that is, I also thought about, like, what do you call a group of ducks? If we're going to call a group of assessments something, what would we call them? And I was looking at what birders call ducks, and it turns out they call a group of ducks a lot of different things. So I'm like, okay, that's interesting. And if you look at birds just in general, there's an incredible array of interesting words being used to describe a collection of them. So I presented a few of them here for you. You can go ahead and take a second here, pick out your favorite. There's just a lot of really good ones to choose from. But what it basically taught me is that I can basically pick up any word that I want, choose any word I want, because there's a lot of random words here being used to describe a collection of things. So I am using a collection of stock assessments. I call them a continuum. And why do I call them a continuum? I do believe that the way that we can view the vast majority of our stock assessments is that they are connected. and they can be, through that connectivity, maybe even modeled in a continuation framework instead of having a lot of separate models. So let me describe this unifying framework. I use stock synthesis. You can use basically any sort of flexible system you choose, stock synthesis being one of the more widely used. Incredible team working on it at all hours of the day. And so it's a very, very appealing system to jump in and see if we can make a continuum with it. So there are many bespoke modeling options out there, but the intent here is to gather that continuum under a common framework. And so the idea here is, how do we do this, right? And we can start with this idea that complex modeling frameworks can actually be restricted or reduced down to being just simple calculators. And if you think about this, if you do stock assessments, if you went in and pre-specified all of your information, all of your life history information, your selectivity, whatever it is, you told the model you know everything, and just allowed it to estimate, say, the scale of the population, you could, by just adjusting the different inputs, get different values. Likewise, you could tell it to, say, calculate the size of the biomass based on what you think the current stock size is, relative stock size. And so you can restrict these models completely and then tell them to do certain things, and they will spit out, just like a simple spreadsheet would, how much of the population is out there and how much is still there, etc. And so the idea then is, well, if you can restrict it down to being a simple calculator, what if you just start to free it up by adding a bit more information here and there that allows you to estimate either more parameters or incorporate more uncertainty? And so about a decade ago, we started playing around with this in stock synthesis. And here is an example of a variety, and here are papers that over the years we have applied these different variations of stock synthesis to catch-only models. So literally just using catches in life history in a Monte Carlo sense to estimate a sustainable catch. There are, you can add to those catches abundance indices, and you basically get either an extended version of the simple stock synthesis or an age-structured production model. You could add removals plus just size and or age compositions, and you get something that we call a catch plus length model. Could be catch plus only ages, all the way up to adding everything together. And so you can go and you can do simulation studies, you can take a look at this, and here's just one example of taking a complicated stock assessment and stripping it down to its catches only, to its catch and index only, to its full model. And you can go and you can look at comparisons to see how well did those models do. And in this case, you see these differences from these other models being based on the fact that these ones did not incorporate length composition. So you learn something about what the information content is in any given assessment. So that's pretty useful. But what we also see is that in some cases, especially for like relative stock status, you do a fairly good job, plus you're incorporating a whole lot of uncertainty in these. And so they are showing in many instances a fairly decent estimation of the things that you care about that you can then take and apply in your management system through buffers with using the uncertainty and et cetera. And so there is a connection here. And the other nice thing here is if you, as this demonstrates, get more information, you can just add it to the same model and build it up towards the full model. Now, it's very rude to present a bunch of simulation testing into one slide and expect everyone to get everything. Not what I'm doing here. I am showing it to you just to show you that we did simulation testing on this catch and length model, and we did it for a variety of different setups. But the big takeaway is that these models can, under certain conditions, do a pretty good job of estimating your stock status and other things that you care about. And so again, kind of proof of concept that catch plus length models can take you a fair bit of the way. And so we now enter this system of kind of moving up the assessment ladder from data limited to data moderate to data rich, however you want to term these things. We're going from very limited information and just adding it as we get it up through hopefully more data rich situations. What's nice is that you can create comparable results and have that ability to incorporate new data when you get it. And you can see that there should hopefully be a reduced uncertainty as you include more information, though beware, as you fix a bunch of parameters, you might be overestimating how much you know about the population, thus underestimating the uncertainty in some of our data limited models, which makes us have to kind of seek out other ways like sensitivity analyses to really incorporate all of that uncertainty that's truly there. All right, so with that there, we set the stage for setting up maybe a more user-friendly way of doing this. Now you can go and you can figure all of this stuff out yourself. What I tried to challenge myself with was coming up with a tool that would be accessible for folks to do all of this. And I call it the Stock Assessment Continuum Tool. I used to call it the Stock Synthesis Data Limited Tool a couple years back, and that was mostly because it was focused heavily on configuring stock synthesis in these really bizarre data limited ways. But what became very apparent pretty immediately was, well, you can just keep building those all the way up to the most data rich. So a name change was in order. And so now I am adopting the more inclusive Stock Assessment Continuum Tool to demonstrate that you can build both very complex stock synthesis models as well as do these very bizarro data limited versions. And so if you get this presentation, you will you can click that link that I just clicked, and it will take you to the GitHub site, which houses the tool. And in this, just a quick tour, you will see that it tells you how to install this. It does require installing a fair bit of R libraries and some other libraries that are really important in processing stock synthesis output and so forth. It then shows you multiple different ways in which you can run this tool. And so if you're not familiar with that, these instructions are provided for you. And once you got this tool opened up and you got the libraries working, and I will say some of the most common thing that people run into when trying to use this tool is that the libraries didn't fully install properly. And boy, our computers have invented many different ways in which to frustrate us through not incorporating either our library dependencies or not pulling things off GitHub appropriately, whatever it may be. My recommendation, if you run into a problem, certainly you can reach out to me, but definitely check to see if your libraries weren't fully installed. And so if you got that far, you've pulled up the model, you can then walk through the many examples that I have here on how to use and explore the tool and so forth. And I have good colleagues in Brazil who help me present and put this sort of front-facing tutorial for you together. So I thank them, Evie and Louise. So it's just wonderful to have them. Gustavo, so wonderful colleagues who's been doing a lot of work down in Brazil on applying this model, and I've learned a lot seeing him use it. And so this is another invitation for people. If you do start using this tool, please reach out because I will learn a lot from you and would like to make things better. But I'm not going to walk through the tool this way. I'm going to launch the tool, and when you do launch it, it will look something like this, and I actually have a launched version of it right here. This is what it will look like, and if you click on here, it will send you to the Stock Synthesis GitHub. This will explain the types of models that you can run in here, and you can access the Stock Synthesis HTML version of the manual here. Stock Synthesis came out with a new version just yesterday, and this tool is updated with that new version. So it's running and ready with that new version. And so the first thing I will do before we explore a bunch of stuff here is go back to the slides and find them. And I want to walk through some overviews of the tool here before we get to take a closer look at it. The first thing that you have an option to do is that you can load in your data files. Now, there are example data files when you download this tool from the GitHub. There are example data files that are hopefully pretty easy to set up that will get you really quickly ready to read your data in. One of the advantages of this tool is that even for power users of stock synthesis, if you just want to get some basic quickly running SS models that you can then manipulate yourself, you can read them in through here and get it running pretty quickly. I found that very, very useful in production stock assessment. So as you read in your different data types, this tool is going to be alerted to how it needs to configure stock synthesis based on the types of data you have. Now, if you only have catches, that means you would do what we call the simple stock synthesis catch-only approach. That is a very different treatment of the stock synthesis approach than doing like a normal stock synthesis. So this will configure those files appropriately. Likewise, if you're doing a length-only model, you have no catches, only lengths, you can do a length-only version of stock synthesis, but it takes a little bit of a different setup than you would normally do. And so you can see here, length only, length and age only, catch and length, age structure production model, all the way up to full stock synthesis. You can do all of those things, and depending on what combination of these 4 data types you have, it will appropriately set things up. You can also conveniently clear your data if you wanted to explore different versions of the model with and without data sets, so you can clear data that way. The other important way of setting things up here is that if you have already set up a stock synthesis model and it's already run and you have stuff doing, and you want to go in and manipulate it in some extremely complicated way, you can still use that model file in this tool by clicking this option, not reading in data, but just clicking this and then going down and putting in the name of your file and putting it in the right folder. It will basically run that, create the plots, do some data weighting if you choose to. It expedites some things that you can do on the model if you run it through here. So even if you are a hardcore power user of stock synthesis, you might still find some nice applications of this. You will notice that there are a bunch of different tabs up here. I will be walking through those. Those also, I think you will find very useful even if you're a power user for stock synthesis. So we'll get to those in a moment. All right, so when we do model input, you would say, read some data in, and then it will show you some pictures of what your data look like. It's very good for us to be able to look at our data. First thing you will see, if you put some catches in, you'll get a catch time series. If you happen to put some lengths in, you will have lengths by fleet and by sex overlaid by year. And so you can kind of get an idea of what your data look like. Let me walk through these and then we'll set these up so you can see a real life example. If you scroll down a little bit more, it will ask you, once you have your data in, to put in your life history. And you can either estimate any of your life history inputs, or you can pre-specify them. And here I have them all pre-specified, but what I wanted to show you is once you start to put that in, it starts to create different plots. One is a decay plot based on your longevity or based on your natural mortality, and it uses the Hamel approach of basically back calculating what your maximum age would be from that M. And by doing that, it gives you a check to make sure you entered in your natural mortality correctly. Very common to put an extra 0 or forget the decimal or do something weird, and this should really quickly show you that your species isn't living to 1,000 years or 0.01 year or something like that. Additionally, you can put your growth and your reproduction in, and so you'll get growth curves here. You can see that you can either do it a one-sex model, or if you click on here, male-specific values, you can do two-sex model. You can do offsets from the males from females if you choose. But what I find very handy is being able to plot, say, your maturity ogive, some important points on that, L50 and L95, onto your growth curve, again, to make sure that the life history that you're putting in makes some sense. The other thing it does is it plots L infinity and L maturity for unsexed for the females, so you can quickly see how much immature lengths or comps are being taken versus how much L infinity, how much of the compositions are at or above L infinity. These are really quick and dirty indicators to tell you whether you might be in for some trouble, depending on your length compositions related to those. So those are some nice things to be able to look at. If you scroll down a bit more, you'll have the option to set up your selectivities for all of your fleets and surveys. And when you do that, you have the option of both logistic and dome-shaped, and a lot of flexibility in both. You will notice that for those of you familiar with doing stock assessments in stock synthesis, you have the opportunity to turn parameters on and off through the phasing, negative phasing, turning parameters off, meaning you pre-specify, saying you know what they mean, and positive phasing, meaning you're going to estimate them at some point. And you have full flexibility to do that. So what's nice about this is you have full flexibility across as many fleets as you have to have a mixture of logistic and dome-shaped selectivity in the length space. I do not have it set up for age-based selectivity at this point. All right, so just as a quick demonstration, because I want to highlight a couple of other things before we move on. Here we go. So again, if I take away the lengths, you will see that there is a very different setup. You notice these things, you just take that mental picture of that. Whereas if I load in lengths, those go away and you have a different looking setup. That is the difference between a catch-only version expression of a stock synthesis model versus a catch and length models. It gives you different options. Here is where you would toggle on and off the ability to estimate parameters or pre-specify or fix all of them. You'll note here also that if you know about data weighting and you want to apply data weighting, you can just click one of these buttons and it will apply that data weighting to that model run. We've gone through the abilities to set up selectivity and life history. Here you can also estimate recruitment and put in your bias correction if that means something to you. If you use stock synthesis a lot, you'll know what all of that means. Those options are there for you. The other thing I wanted to highlight here is that in addition, you can always play around with the dimensions of your model and all these things, but I add a bunch of kind of power user options for stock synthesis. You can turn variance estimation on and off. You usually want it off if you're exploring models, want it on if you want to get your final model. You can also add additional SS commands. And what I want to note is if you hover over all of these things, they all have explanations. And so this one has an explanation of the test step option that you could use as an example of an additional command in SS that you'd want to run. You just have to list those here. You can turn plots on and off. We have an executive summary table that we often use. You can turn that on and off. You can turn phase estimation off. You can specify catch units, either in biomass or numbers here for all the different fleets. You can determine whether you want to use one growth morph or 5 have as a setup. Any more than that, you would have to go in and mess around yourself. You can add additional variance on your abundance indices by clicking this. You can use the sex equals 3 option for either lengths and or ages by clicking these choices. You can add a custom aging error matrix in here. The default, if you have ages and you don't put anything in, is that it uses the precise and unbiased default matrix to run your ages, but here you can set up an aging error matrix that will be whatever you would like it to be. And more dimensionality here for you. It bases the dimensions of length bins on the L infinity that you put in, as well as the plus group being based on your national mortality. You can always change those. Now, lastly, just to get down to the bottom here, the important point here is that you have to name your model something, and once you name it, it is going to, and you run the model, it's going to collect all of the model runs, all of the plots, everything is collected into the folder, given whatever name you've given it here. That is found in the scenarios folder of the tool. So that'll be on your desktop in a folder waiting for you. And what's really nice about this is you can run a model and then say, I want to change natural mortality to something else, change it there, go down, rename this. If you don't rename it, it's going to overwrite the other one, but rename this and you quickly have and can accumulate a lot of sensitivity runs that way. Lastly, I've attempted to try to, while I am a fan of making people put in all of this information because it makes you think about what you're putting in, how you're treating it, and so forth, doing it like 100 times can get a little annoying. And so I have attempted to save the session. So if you click this, it will give you this crazy long thing that you will copy and paste it somewhere in a text file. And if this thing fails or disappears or whatever, crashes on you, you can put that big long link that I just showed you back in here and it will recover all of your inputs. Now, sadly, it does not always work and I have no idea why, so that is something I'm trying to improve. I'm also looking to improve on ways to maybe expedite some of the inputs a little bit. So things to work on. And once you have all that set up, you hit run and it runs the model. And once you have it run, you can know that everything has been saved to your folder. So you have everything. You can jump over to the model output if you want to see just some key things that are outputs. And if you scroll down, you'll get a bunch of tables that you can sort and look through. And so you can look at the model, you can look at the outputs that way, but also know that the report file and every other file Stock Synthesis makes for you is saved for you. Now what I want to do, so that's just real basic overview of vanilla model running in the model. I want to just really briefly in the last, say 10, 15 minutes, show you some of the other functionality in this tool. And so I'm going to go tab by tab. I'm going to walk down each of these tabs and kind of show you what is going on. So in the model efficiency tab, this is where you can run mini Bayesian models. And this is based on the work of Cole Monahan and others, and his AdNuts program, or 80 nuts, that allows you to do quicker Bayesian runs, hopefully. And one of the philosophies behind it is that you should go in and deal with some of your parameters that really aren't doing much in the Bayesian space. So one of the things that you can do with this tool is that you can select a model that you've already run wherever it is on your computer, and you can go down and basically just run, there's a go button down here. It will run a mini Bayesian model for you and produce these pairs plots that will show you, for instance, things like this that show you, all right, that is not doing any work for you in the Bayesian space. You might as well fix that parameter. And it's an opportunity to maybe increase the efficiency of your model run and not get you in trouble if you want to do one Bayesian or two, just even in MLE space, do a better job of running these models at a shorter amount of time and all of that. So this tab allows for that really nice, quick model efficiency, but it also rolls right in. You can pick the NUTS option. It rolls right into doing Bayesian models using the NUTS program and all the output that comes from that. It gets that for you. So with a with a click of a button to navigate you to a folder you want, and a click of a button here, you can do some real nice model efficiency evaluation and then roll right into some Bayesian models if you would like. If you've chosen, now the next thing, if you've chosen jitter explorations, and jitter explorations is something that we typically do to make sure that our models are converged, that we can reproduce the model values that we are saying are our best fit model and things like that. It will, you can click that button in the tool and you run jitters that way. And once those jitters are done, it chooses the best fit model, hopefully the one that you went in with, and then reruns the model with the Hessian on and gets you a variance for that final model. But it also produces some jitter plots and other things that will pop up here. Those jitter plots are also in the folder run that you would have produced for that model. So that's all waiting there, sitting there in the scenarios folder for you to get. So anything you see on these things are just kind of previews just to show you your results, but they're all contained and saved for you in the folder. Likelihood profiling, tried to make this easy. You can go and you can pick a, you go choose a model folder, a model that you've already run. And if you would click on this, and actually what I might do, pop over here really quick just to show you. If you click on here, you can pick a variety of different things you might want to run likelihoods for, and it will do them in sequence. So you can pick which parameters you want to run, and then you can pick the low, high, and sequence step for each of those parameters, and then run the profile. If you scroll down farther, you would also see that there is a multi-parameter likelihood option that if you set up a simple little CSV file of the parameters that you want to run through and how they change, it will do a multi-likelihood, parameter likelihood for you and produce the plots. And this is one example of a plot that will produce. It produces the likelihood component plots as well, all of those plots, and then the comparison plots, all of the typical plots that R4SS uses. And this is a good time to say that this, I am leveraging the fine work of so many good people who build out on R4SS, just a variety of libraries that are out there. I try to leverage them as much as possible and put them into this tool for accessible use. And I try to keep this tool as up to date with all of those changes as I humanly can. All right, simple. If you ran, if you want to do a retrospective, you can go in there again, pick a model file, pick what years you want to do the retrospective from for, hit this, and then it will produce things for you. That one's pretty straightforward. It will also produce all of the other outputs that the retrospective functionality offers, which is tables of Mohs row and other metrics. Okay, for sensitivity plots, this is a really useful one. You have, say, you've ran a bunch of models. You can go, and as long as all those models are in a common folder, you go pick that common folder, and then this button will, for all of the models that are in that, let you choose a reference model. And then for all of the models that are left, it will allow you to choose which ones you want to put into a comparison plot, an R4SS comparison plot. You can put your target and limits here, and then below here are some specific values for the relative error comparison plots. It produces those as well. Here I'm just showing you some typical SS comparison plots that it would produce for you. And as always, it's putting all of those plots into a folder for you and saving them all for you. You get a little preview on this page. And then lastly, there is an ensemble models tab that lets you, again, go into a directory. If you have multiple models in that, you can choose which ones you want to combine, and then it makes you choose what weights you are going to apply to each of those. It will then give you violin plots for 5 different management metrics that we typically care about. showing you how the individual models and the composite model compare. It will then also create these composite time series models for things like spawning output and relative biomass. This is an interesting one where you have a bimodal thing that comes in and actually starts to agree and then goes bimodal again, whereas there's a little less bimodality going on with the relative stock status measure. But this is a very quick and simple way to do some ensemble model exploration. All right, and so this is a map here of different, basically of the stock assessment continuum from no data to whole lots of data. And this is structured around what data you have, removals, biological comps, and indices, whether you do or don't have them. And this is showing you that for the large part, what is actively available in the Stock Assessment Continuum Tool is most of these. What's not in there is all these very strange little indicator-based methods that are model-free to begin with, or things like productivity, susceptibility analysis, those sorts of things. Those are just not model-based methods. So you're not doing everything, but you're doing a whole lot of good stuff in stock synthesis, and hopefully this tool allows you to do them in a more streamlined way. Another really useful thing that I tend to do with this tool is I build up my models, or in the reverse sense, you can peel away data sets from stock assessments, and these are examples of more recent stock assessments where just started putting in data one by one just to see where the signals are, to learn what information are these data sets containing and how are they being played through the model. So this you could do pretty easily in the tool. So some takeaways, and I'll finish up here, and hopefully leaving some time for questions or recommendations. For the tool itself, I hope that it's promoting a streamlining, a common framework that encourages model building instead of discrete model jumping. And you can also pretty quickly build some working SS3 models that you can then make as complex as you want. And so that is also a streamlining, getting people up and running in stock synthesis as soon as possible. Comprehension, understanding what our models actually are doing, stripping down assessments to the components can reveal that information content. It can also highlight some of the assumptions that are being made. As you get more data limited, you tend to make more assumptions. And so understanding I have to start fixing these models when I start to take out certain data types. Or I have to start fixing these parameters when I start taking out different data types. And then innovation, taking advantage of advanced diagnostics, the flexible the capability and capacity of something like stock synthesis, the creative possibilities of the platform. It's really exciting to work in stock synthesis. And just, again, the amount of people working on diagnostics and plots and just all of these other things to support how do we interpret the models that we're creating. It's just a really wonderful environment to work in and just full of really great people. So what's next? User friendliness. I'm always trying to make this easier. It's harder on me trying to develop it. Obviously, I try to put in some user warnings. I try to avoid the crashes before they happen, but they're still going to happen to you. I'm going to do my best, but it's on my mind to make it as user friendly as possible. But there's a balance that I need to maintain. Not all stock synthesis features are ever going to be in this GUI, and nor should they, because if they did, it would look like you were flying a plane, and I don't think we want that. So I'm trying to find that right balance of just enough to get you really going in many circumstances, but then the encouragement is you can go in, once you really start understanding what you're doing, you can go in there and manipulate the files any way you want and still read it back into the tool or run it your own. And maybe you'll come back to the tool to use it to do the model efficiency or plot sensitivities or do likelihood profiles, all those sorts of things. I do want to add either SSSIM or MSE capabilities, so you can start to explore those sorts of things. And then lastly, FIMS has this just wonderful. I mean, that's where we're moving towards, right? And it's trying to unify these general integrated modeling frameworks, all of these really complex models that are around the world, trying to find a unified framework that we can work in. And it just makes all the sense in the world that we'll want to also incorporate all of these funky little models as much as we can, all these data limited ones, so we can sweep in this stock assessment continuum right into FIMS and into the future. So I think that's all I have for you. Here's our nesting doll of stock synthesis. Thank you so much for your time. There's my contact information. If you have any questions, ideas, or you want to talk right now, I think I got about 10 minutes before a class comes into this space. Thank you.
Thank you. That was a really fantastic presentation and a very impressive shiny app. So thank you for that. Audience, we have about 10 minutes, as Jason said, to answer your questions, and we really would love to hear them. So please type them in the questions chat box, and I will read them to Jason. But before I do that, I also encourage you to download today's slides. They're under the handouts menu before you log out so that you have access to all that great information. And one more thing, I just put a link to the NOAA Central Library YouTube channel. The recording of today's webinar will be there in just a few hours. So if you think there's somebody who did not attend who would really benefit from hearing Jason's presentation, please send them to our channel. All right, so the questions are beginning to come in, Jason, and I'm going to start with a recommendation that came in fairly early in your presentation. And it is a recommendation that for a grouping of birds, you did not have Parliament of Owls in the group. So
I ran out of space. That's a good one.
Yeah, it's a fantastic one. Excellent. Our first question is, it says, great talk, Jason. I'd like to hear more about peeling. Could one change the sampling density or scale of a data input, for example, the survey index, instead of removing it outright? Or would that require the user to modify the input data directly?
Okay, so I'm going to try to answer this regarding the tool. The way that the tool works is that you have you would have an input for your indices, and you would load that file in. And what I'm hearing is that you might have an alternative version of that data. If you do, you can set up a complete, just a companion or just a separate CSV file for that index, and then just go up to the tool, just read that one in, and then boom, hit go and let the model run again. I mean, rename it. But yeah, you can. I highly recommend when doing. I mean, there's the minusing of data, right, which I showed the peeling, but then there's also the alternative forms or treatments of data. And you can absolutely have different versions of the data sets that you read in to the model. And if you have those set up, you can just really quickly pull those in, it'll overwrite the other ones, and you can move on your way. I hope that's answering the question, because it's a good point that we don't always just take data in and out. Sometimes we modify it. Sometimes there's a treatment to it that's a little different. And I have found success just setting up separate files and making that a very rapid process.
Thank you for taking on that question. This next question asks, do you include user warnings about statistical assumptions / low statistical power, or just user warnings about potential code errors / cleaning input? I have just made my first research GitHub repository public, so I'm very interested in how to make code bases user-friendly.
Boy, yeah, there's definitely people way better to answer this than me, because I'm not a big time coder. I code a lot out of survival, but it's not my upbringing. And so I will not be able to give you all the best advice. What I can say is the warnings for stock synthesis, it's not necessarily, it has a lot of built-in warnings itself for warnings about how the model is running and what's going on with the model. And so those are captured in a warning file that I actually print to the model output, so you can read that. You can also go in and open it up yourself. I just make it more convenient. So most of my warnings are, you forgot to put in Like you don't have all the fleets put into your selectivity, or you forgot to put this file, this input in, those sorts of things that previously people would run it and it would just crash the model and they'd be sad because then they got to set it back up and figure out where they messed up. Now it just stops them and says, hold on. So I have a lot of those. I don't so much have the warning of, hey, you're making this great big assumption, but if what it is you're coding up and whatever application you're creating, if you can do that, and again, stock synthesis does a little bit of that for us anyway, but if you can do that, absolutely. And I will think through, I don't know how many places I would have an opportunity to do that, but the concept is an extremely important one. I'll keep it in mind now that I'm looking through the tool, if there's places where I can warn people about certain things. Thank you.
Thank you. We have another question here. It asks, for length-only models, LBSPR and other simple tools allow for a full exploration of life history parameter space through Monte Carlo analysis, 10,000 of model runs. SS is relatively slow for this, given the massive output. Given the massive outputs it produces. Is there a way to drastically simplify SS outputs in order to run large Monte Carlo analyses?
Yeah, so I mean, you are right. Like I said before, stock synthesis is a big, bulky calculator when you simplify it. And so there is some overhead. Rick Method, obviously one of the creator of stock synthesis and ongoing developer of it, has produced shorter report files, because a lot of the stock synthesis overhead is writing files many of the times, and so he's helped shorten that down. And one example of this is doing the catch-only model, which is Monte Carlo in its application in this tool. So that's why it's kind of a separate thing. When I run the length only here, as you said, I'm not doing Monte Carlo draws on the uncertainty in the life history. It is treating the uncertainty in the data differently than length-based SPR is. And so I think there's trade-offs between how uncertainty is being measured. As you noted, we could do sensitivity tests. You can do profiling. You could do a bunch of these things that we typically do in our stock assessments that would get at similar stuff that the Monte Carlo would. But I don't think we're ever going to, I don't know, maybe someone's got a real super nice computer that can speed it up. But there's always going to be a little bit of a time investment in doing this. But what you're gaining, and I do want to emphasize the fact that what you can gain is that you have the flexibility of doing dome-shaped selectivity. You have the flexibility of certain life history setups that are a little different, and multiple fleets, tracking multiple sexes. There's a lot of flexibility. So with the overhead that comes with using a framework like this, you also, though, inherit a lot of flexibility. So the trade-off for me has been one that I've tended now to kind of do. I've tended to needed to use the flexibility in the length-only models that I've applied that comes with this approach. But I also have a stochastic version of length-based SPR that I have, and I use that as well sometimes. So it's a good consideration, and it's a true one. There is some overhead doing Monte Carlo in this. If folks got a good idea on how to get that more efficient, I'm all ears.